Hello everyone, this is the second one in the series. We are looking at quadratic equations. So we'll figure out the relationships between the roots, vertices and stuff, okay. So this will be a slightly longer video, just have patience and see the whole thing. So you're looking at a standard quadratic equation, looks like this, okay. So to take an example parallelly, say we have y equals 2x squared minus 28x minus 80, okay. So when we factorize this, the process is, first of all we take out whatever is common, so 2 goes common straight away, leaving out with x squared minus 14x minus 40. Let's make this plus, okay, yeah. So now we'll split the 14 in such a way that the product of the two terms will be equal to the product of the first term and the last term, okay. So obviously it would be negative 10 and negative 4. So x squared minus 10x minus 4x plus 40. And finally this gets factorized as x minus 10 times x minus 4. So keeping things in the same way, we would be able to factorize as x minus r1 times x minus r2. These are the factors. So when y becomes 0, one of these has to be 0, so that means x will be either r1 or r2, which we call the roots of the quadratic, or also the x-intercepts. Similarly, if I have done x equal to 0, then I would have got y equal to, so 0 plus c, so y will be c, this is the y-intercept. So here the y-intercept is 80 and the roots are 4 and 10. So if I try to draw a graph, my curve should pass through 80, somewhere there, a 4 and a 10. Obviously this is not to scale, so the curve has to go like this, then turn around somewhere and move back up. Okay, this is how the curve will look like. Observe that this exists, so there is a line of symmetry. Where is that line? Passing through, this is 4, that's 10. So the average of those two, right? So the line of symmetry passes through x equal to 7. So here in this way, the line of symmetry equation would be x equal to r1 plus r2 by 2. Okay. Now, once we have this, so let us multiply that out. Okay. So y is a times, so we have x squared minus xr1 times minus xr2, so r1 plus r2 common, and then plus r1 r2. If I expand it, this would be ax squared minus ax r1 plus r2 plus a r1 r2. Comparing this with the original form here, we get, see, ax squared is matching, right? So this middle term here, ax r1 plus r2 should be b x. So we get b is minus a r1 plus r2, from which we have an important result. Sum of the roots is minus b over a. And comparing the constant term there with c, we will get r1 r2. So the product of the roots is c over a. Okay, these two are important results you should keep in mind. So since r1 plus r2 is minus b by a, this therefore becomes minus b over 2a. So that means this point, the vertex 7 comma something, that 7 is basically this, minus b by 2a. Cross check, minus of minus 28 is 28 by 2 times 2, 4. 28 by 4 will be 7. Now, if the vertex is, coordinates are, let's say hk, then we already have h to be r1 plus r2 by 2, which is minus b by 2a. And to get the k value, we are going to simply substitute this h in the equation. So ah squared plus bh plus c. So here in this equation it would be, if I plug in 7, let's plug it in here, it is easier to plug in. 7 times 7 minus 10 minus 3 times 3. So minus 9 times 2 minus 18. So that means the vertex is 7 comma minus 18. Here it is h comma k. One last thing here to note, This same equation can be rewritten in a slightly different manner. So taking the 2 common, x squared minus 14x plus 40 can be split as we complete the square with this term, giving us x minus 7 whole square. So what is that? X squared minus 2ab, that's 14x, okay. We will get a plus 49, but I need only 40, so I need to do minus 9. So we will have 2x minus 7 whole squared minus 18. Observe the 7 and the minus 18 are here, 7 and the minus 18. So that means if I know my vertex, in terms of the vertex I can rewrite this equation as y equals a x minus h whole squared plus k. So these are the important properties, okay. So what are the properties? This is number 1, then number 2, 3, the 4th one, then here we have the 5th one, then coming back here number 6, and finally number 7, okay. These are the 7 basic rules. Now moving on, there is a formula with which we can compute the roots also instead of factorizing. So if I have y equals ax squared plus bx plus c, then y equal to 0, you can solve directly using the formula here. Okay. From here we have 3 rules. Since this b squared minus 4ac is inside the root, so b squared minus 4ac greater than 0 would mean there are 2 real roots. Equal to 0 would mean 1 real root. Means no real roots. Because if it is less than 0, then we have to take the square root of a negative number which will be imaginary. So remember these 3, and if b squared minus 4ac is a perfect square, that means we are going to get rational roots, else the roots will be irrational, okay. One last property regarding the modification of roots that we need to know. So if y equals ax squared plus bx plus c has the roots r1 and r2, then point number 1, if I replace x with x minus k, so in place of x I have put x minus k, my roots would now become r1 plus k and r2 plus k. The reason is simple, think of x minus k whole square as some capital X, okay. So if you solve this, and if you solve this with capital X, you are going to get the same roots, right? But that time you would have capital X equal to r1, but capital X is x minus k equal to r1. So small x will actually become r1 plus k. So the roots will become k units more. In the same way, if I replace this with plus, then this would become minus. Point number 2, if I have y equals a x divided by k whole squared plus b times x upon k plus c, so I have divided the variable x by k, my roots would become r1 multiplied by k and r2 multiplied by k, right. The last one, if I replace x with 1 over x, means I take reciprocal of the x, which basically translates to this equation becoming cx squared plus bx plus a, basically meaning that we have just swapped the coefficients a and c. Then my roots would become 1 by r1 and 1 upon r2. So these are the 3 rules for modification of roots. So this kind of is the basic idea on which more or less 99% of all quadratic equation questions will be based on. Thanks for watching.